Hi again. My talk today will show you how to provide Jupyter notebooks for small groups of people on the same infrastructure in under 10 minutes with the help of the littlest JupyterHub. So I'm Georgiana, and I had my first interaction with JupyterHub and the open source world, as a matter of fact, through an outreach internship. If you don't know already, the outreach internships support diversity and inclusion in the open source and free software world, and it was a super inspiring and amazing experience for me. Now, for the past year, I've had a chance through the CCI grant to grow as an open source contributor, and as well as a Jupyter community member by working as a JupyterHub contributor in residence. So before starting anything, I want to show my support and thank you again for supporting the open source communities and for this amazing opportunity I had. Okay, so the Contributor in Residence project was about finding ways to support the JupyterHub sub-projects by helping the daily tasks that happen around the project. So things from fixing bugs, writing or improving the docs, answering support questions, all the way to adding bots or writing blog posts and give presentations. So for the JupyterCon conference that happened a few months ago, I created this poster that describes my achievements. There's also a link, a JupyterHub on the YouTube channel of the JupyterCon where I also gave a short presentation about it if you want to find out more. Today, I'm not going to be talking about these little achievements, but instead, I will be showing you a project that is super dear to me, that I've been helping maintaining this past year, called the Littlest JupyterHub. Most of you are probably already familiar with the Jupyter notebooks, but now let's find out what JupyterHub is and what's with the tiniest of the hubs. So JupyterHub is a project that helps bringing groups of people together on the same infrastructure, and it provides them access to Jupyter notebooks on that specific computational environment. So in order to support multiple users, JupyterHub needs an authenticator that decides who is allowed or not into the hub. It needs a spawner that creates that notebook server for each user that logs in, and it needs a proxy that knows how to send the user to their associated notebook. The little JupyterHub is a JupyterHub distribution. The hub distributions are just hubs that have been configured to serve specific groups of use cases. This was done in order to simplify the complexity of the JupyterHub deployment. We actually call the deployment of JupyterHub without this distribution deploying it the hard way. So for example, the little JupyterHub is a hub that has been configured in a way that it's small enough to fit inside one server. But this doesn't mean that you cannot configure the little JupyterHub past these defaults. So you can still tweak bits of configuration for a better experience. You can choose, for example, which authenticator to use, or which interface, the classical notebook or Jupyter Lab, and many more that are available in the docs. So because the little JupyterHub is single server, it cannot support more than 50 to around 100 users. But this limitation also means smaller costs for the underlying infrastructure because it's single server. It's also less complex than the other distribution that's called Zero to JupyterHub that helps deploy JupyterHub on Kubernetes. But this one is a bit less complex, and this makes it super easily deployable. So easy that I'm going to share my screen now and show you how you can install. So just a second to share the other window. Okay, so can you see this new page with DigitalOcean? Okay, so these are the little JupyterHub docs. On the left-hand side, you can see that you have instruction on how to install it on different cloud providers, including on your own server. I'm going to be following these steps for DigitalOcean, and I'm going to need this command here that I'm copying it. Okay, so first thing you need to do in DigitalOcean is to create a droplet. That's going to give you a server. The little JupyterHub currently offers support for Ubuntu. So we're going to go with the default here. So choose a plan, again, the default, the data center region, and the most important part is to check this box here for the user data and paste this the command from the docs. What this does is downloading the TLJH installer, execute it, and then set the first admin user that will be allowed to access the hub. So I'm gonna also add here a pretty new flag. To show a progress page, and you'll know what I'm talking about with this, where I'm going with this. Okay, so I already have here a droplet and a hub already spinned up, because it takes around 10 minutes for this to get created, but I will wait a little longer to show you that progress page. So the progress page was created in order to get rid of the requirement of knowing how to SSH into your server. So prior to this progress page, if after 10 minutes your hub didn't show up at that IP address, you will freak out and had to SSH into the server, see if that's stuck, if it just needs a little longer. But with this page, you can just click a button from your browser and actually see the logs. So I'm going to copy the IP address of this server, and hopefully, okay, so this is a progress page that tells you to wait, but you can also have this button here to see the logs, to see in which state TLJH is currently in. So right now it's setting up the hub environment. You have to manually refresh this page in order for the logs to update. But if you stay on this page, this one gets refreshed every 10 seconds, I think. So when TLJH is up, you will be redirected to your hub from here. So now let's go back to the hub that's already running, and we will check on this one at the end to see if it's up. So copy the IP address here, and you already can see the JupyterHub login page. So as I said, the first user that can log into this hub is the one that I set in that installer command. And at this point, I can set whatever password I want for it. This will be this user's password from now on, but you can modify it if you want. Okay, so now I have a notebook server and I have a hub. So at this point, it's no different than the notebook, because I can open up a notebook from here. But the whole point of this is having other users too. So in order to add new users, you just have to go to the admin panel here. You can see that there's only one, that's me. So I can add here other users. Let's say user. I can also make other admin users. So the admin users are the ones that can configure the environment for all the other users. So the way that the little JupyterHub works is by having a shared Conda environment that only the admin can configure, and the others can enjoy those packages already installed there. So now that I have an admin and a regular user, I will show you a nice thing with NBGit puller. So the little JupyterHub already has NBGit puller installed. So this works out of the box. So if you don't know already what NBGit puller is, I'm going to show you now. So let's say I have a public repository where I have a notebook. This one is binder ready, so it also has the requirements, the Python requirements needed to run the notebook. So let's say I want to share this with fellow colleagues, so they can rerun the experiments I have in the notebook, evaluate, and other things. So for this, I need to copy the address to this repo and go to the NB-Git puller link generated page. This is in the NB-Git puller docs. I'm gonna paste the address here, and then the address of the hub. Okay. So this is where my hub is running. And then here you can also have the branch and how to show off this this notebook the first time it gets open. So I'm going with JupyterLab here. Okay, so you can see that I already have a link here. So if I open this link in another tab, what will this going to do is clone that repository inside the home directory of that user. In this case, the admin user. And I'm going to have access to that requirements file and to that notebook. So right now, if another user clicks it, you'll see right now. So I'm the admin. I'm the first one that clicked this link. So if I try to execute, you'll see that I don't have the packages needed to run this notebook. But what I can do is open up a terminal. Sorry. Open up a terminal here. And so we can see that I have the binder example here. And actually install the requirements. So this is to preserve the environment. Pip install -r this requirements file. So at this point, I'm installing the requirements for all the users. So next time, and I'm going to show you, if I log in with the other user that's not an admin, if that user clicks the NB-Git puller link, we'll get the same repository, a clone of it, but then it won't have any problems running the notebook because all the packages should be here after the admin installs it. So let's log out from the admin user. And I think I named that user. Very interesting name. Oh, did I? Or just user? And let's see now if this works. Okay. Yay, this one works. Okay, so now I can check that I can run that notebook from the public repository by clicking this link and without me installing anything. Okay, so again, that clone of the repository. And now if I go to running this notebook, no errors, everything just works. Apart from this one. It's probably an old repository. So this is NB-Git puller. Yeah, so you can see that now I'm using JupyterLab, but this is just because I've put here, I've chosen the JupyterLab link thing, but by default TLJH has the classical notebook interface, but you can easily change that. So for example, this is the classical one. If I go to a new terminal, so in order to change things, TLJH has a command line tool called tljh.config. So this okay, so I'm sorry. So I'm the user that doesn't have sudo rights, so I have to log in as an admin. I should have saved this password. Okay. So I cannot install packages as a non-admin user, but I can do it from here, and I can see the configuration. And in order to change things, you just have to use the set command. I have the tab here with how from the docs with how you can change the graphical the notebook interface. So I'm gonna copy this here and paste it. And then the only thing left to do is to reload the configuration so that TLJH knows that we want that thing. So now if I restart my server, I should go to Jupyter Lab directly and not to the classical notebook interface. This was it. There are many more things that you can do with the little JupyterHub and with JupyterHub in general. You can find most of these things in the docs. And if they aren't there already, just ask for it in a GitHub issues or on Discourse. Thank you.
Hi, thanks. That's really interesting for a lot of use cases. So just wanted to ask, do you have any plans in any case to add support for HTTPS, maybe for maybe using like Let's Encrypt certificates, because yeah.
That's already possible. So the little JupyterHub uses doesn't use the default JupyterHub proxy that's configurable HTTP proxy, but uses another one called traffic proxy. And with that traffic proxy, so traffic offers support for Let's Encrypt out of the box, and you can have there is info in the docs on how to get that that up.
Mm-hmm. Awesome, great. And also just want to clarify, how do you distribute passwords to all the users you have created?
So by default, the little JupyterHub uses the first use authenticator. This means that when a user, so you just have to add users there, and then the usernames are registered. And the first time a user with that username logs in, that is going to be their password from now on. So you don't have to distribute, they get to set those passwords. But you can change the authenticator and use something more complex, even like logging in with GitHub or Google or other providers. So there are many more authenticators available, and you can change this default.
That's very cool. Thanks.
Thank you.
Great, thank you. I think we have time for one more question. So James.
Yeah, right. Very cool. Is this the sort of thing that if I were teaching a class that used Jupyter notebooks, and I do, is this what the sort of Jupyter world imagines people will be using, like one of these per class with the users? Is that a relevant use case, or is there a different spot?
Yeah, this is the specific use case in mind for the little JupyterHub. It's built for small groups. This means small classes. So yeah, not the university wide ones are deployed in a different way, not on a single server, but on a cloud and much more complex.
You set up to 50 users, which is a great limit.
Yeah, exactly.
Right. So can it connect with university authentication systems?
Yeah, I think so. So JupyterHub has a generic authenticator that you can inherit and like make it work with your institution if it isn't already there.
Fantastic. Excited to try it. Thank you.
Thank you.
Awesome, fantastic. Thank you very much. We will move on now to the Jupyter real-time collaboration. Eric Charles.
Hello, I am Eric, and I'm going to talk to you about the Jupyter real-time collaboration, which is like Google Docs for Jupyter notebooks. So I hope you can see well those slides. Yeah, if it is not, please. Okay, thank you. So I am Eric. I am founder of Data Layer, which is my company, and I am committer for JupyterLab, Jupyter Server, and Jupyter RTC project. And I work also for QuantSite, which is a consulting company in the Python and Jupyter ecosystem. So I'm going to start with a demo. And this is not the demo of the final deliverable we're going to ship in a few months, but it is a demo which shows what has been done even last year in 2019 and what I have done. So a lot of people have contributed to that initiative so far in the JupyterLab ecosystem. There has been a few pull requests, a lot of commands and issues opened, and what I'm going to show you is a port of that work being done last year on the August branch of JupyterLab. So let's move on. Here are two browsers. So we have Chrome on the left, and we have Firefox on the right. And I have a simple notebook, and what you see, I don't know if you, I hope you can see that this is very small, but I move the caret here, and I have also another caret here, which is a caret on the left, on the right side. So if I do hello, hello CiteAs, you can see on the right side what I type. And when I run this in Chrome, it's also shown on the right side. So I do like x equal 4 or equal hello again. That's it. We change from the left to the right, and reverse also. If I type something in Firefox, hello CiteAs again. So everything I type, I'm going to do this. It's more clear. Everything I do is reflected on the other browser. This is what we call RTC. This is what you know when you go to Google Docs, you type something and the other user see what you do. This also works when you move cells, moving cells like this. So I move here also, and so on. This works for output like this, so you have that output area which changes. It works also for Markdown, so hello Jupyter RTC, and on the right I have also RTC. So we have, let's say, a working JupyterLab RTC. So what do? Well, we have a few issues to fix. First, what we have done with JupyterLab, oh yeah, maybe I'm going to show you, sorry. So this is a local server I run. I wanted to show you what it gives when I type. This is very interesting. Every time I type something like this one, you see I have a big JSON that flows between the browser. So this is like, you see the number of lines, the number of the column number, and also what I have typed should show up in that JSON object. And we have a cell model, a version, and so on. So this is what we call the CRDT. This is the algorithm we use. Content free replicated data types, which is an algorithm. There are other algorithms to do RTC, but this is the one we have picked in JupyterLab. And when I say we, in JupyterLab, this is something we have developed from scratch in what we call the Lumino project. Lumino is normally something we use for JupyterLab to show up, let's say, all those menus. This is a Lumino widget. It supports signaling, messaging, and what we have done also is adding to Lumino the RTC functionality. And here I can show you on the server. This is a kind of server we have implemented to collect all those messages and to transfer those messages from Firefox to Chrome. To Chrome. So one issue with that, going back to my slides, is that RTC algorithms are very hard. I mean, because normally when you type something, you need to send to the other collaborator, but you have to solve merge conflicts. So when I type in the middle of a word and someone types at the same place at the same time, something must be done to address those conflicts. And this is what is done with those algorithms we have implemented so far in the Lumino. But there are many edge cases. We also have to deal with performance because you have seen that JSON payload is very, very heavy. And normally what you should do is to encode that JSON into a binary format. So, I mean, we are not allowed to develop that. And we think, and this is a road we take, there are other existing libraries to implement RTC and conflict resolution. And this is what we're going to do. We're going to use those libraries because they are more supported. There is a bigger community around. So instead of developing our own Lumino stuff, we're going to use other libraries. The second issue we have so far is we don't have the notion of identity. So coming back here, I can see, I hope show you again the caret. Where is it? Where are you? Caret. Yeah, I'm going to move here and I see, oh, this is anonymous on the right side. But okay, anonymous doesn't, it's already something. I can collaborate with anonymous, but I cannot collaborate with user foo or user bar. I cannot do that. Because JupyterLab, the implementation we have so far, for example, does not reuse or is not able to reuse the identity of which would be provided by JupyterHub. So we have just seen before that you can authenticate on JupyterHub as a user, but our current implementation does not support that. We don't have any identity, we don't have any permission. So at some point you may say, I want to share and to collaborate on a notebook, but I give you a link and I give you that link with a read-only permission. So you cannot type anything, you can just view and see what I'm doing. We don't have any support either for, let's say, different modes for kernels. So at some point when I change a variable, maybe I want the kernel to be shared with other collaborator, or maybe I do not want that. So that is an issue we need to address. We don't have also, let's say, if I do an output, I've shown you here an output, which is a GIF, but at some point, you know, you may have some IP widgets output with a slider and so on. So far, RTC, we have stops at the cell and cell content, cell output, and cell movement. But we don't have anything within the output to allow RTC. So at some point, if someone develops a widget and wants that widget also to use the RTC channel to collaborate with another output widget, you cannot do that today. So this is something we want to address. And also, all we have done, the current integration into JupyterLab is quite, quite coupled, meaning that there are a lot of impact today in JupyterLab to support RTC. We want to have more decoupling to impact less JupyterLab. This is one goal, but also the other goal, which is maybe even more important, because if it remains in JupyterLab, that's fine. But if we decouple, we are sure we can ship a library, a Jupyter RTC library, which would be used by other clients, your own application or something like NT-React or any existing Jupyter or new client, not only JupyterLab. So this is something we need to address, and well, that's what we do. I'm gonna go through a few slides here just to confirm that in terms of algorithm, you have different options, you have different implementations, YGS, AutoMerge, Freed, and so on. which ensure conversions, which ensure intention preservation, and which support edge cases. And if you want more, I mean, I've given a talk at JupyterCon with more details. These are slides of JupyterCon, so Jupyter conference this year. So if you want to review those algorithms and go deeper into what OT, operational transform, which actually backs Google Docs. Initially, it has been developed for Google Wave, an open source implementation in 2010, which actually is the foundational or first trial of Google to build something real time. And Google Docs now is normally is something like OT, operational transfer. The new one, well, this is something you can try out. Maybe it's not, you don't see the link, but it's quite funny just to see the messaging flowing. You will see that it's quite, the logic behind there is not that easy. CRDT is a new one, which is does not need a server, and this is what we want to use. And there is also a funny website here. When you type hello or hello CiteAs, you see for different libraries, this data structure and the merge logic which is applied. YGS is something we consider. Auto-merge is also something we consider. Yeah, that's it. Okay. We consider, I'm going to also show you, I think I have time for that, a few examples of the current library we have, the current implementation we have. So this is something I have taken from our repository. So if you want to go to the repository, you have the read the docs, and so Jupyter RTC read the docs, and you can go from there to the GitHub repository, and we have an examples folder. And that example folder, if you want to run it, you go to the example read the doc page, and you have all the instructions. And this is something I have just run. When I was talking about library, I was meaning that you could use the RTC library outside of JupyterLab, and this is what I'm showing here to you. So React app, refresh. So talk again. That's it. And this is all the history because you have different messages which flow. And when I remove, I have on the other browser the behavior here, which is also sent via that RTC library. So what's next? We have a lot of things to do. The first one is ensuring we have a basis implementation for JupyterLab. Even if we have those issues I have listed, we have completed that first block A. And we are working today on block B to choose another library, or auto-merge, or YGS, or Freed. We are doing that, trying to compare the performance and the API, the functionality they provide. What is interesting to see is that all those libraries need a Node.js server. It means that if you, as a user, maybe in JupyterHub it has less impact, but if you install Jupyter as a user on your local machine, you would need Node.js, and that we don't want to enforce. We don't want to set as requirement to the existing Jupyter user to install Node.js on top of the Python stack. This is why once we have done step B, we're going to have a look at, what about Rust, which is a way to bind to Python, to compile a server which will support one of those existing library, but in Rust. And binding to Python, we can remove the requirement of Node.js. We move after to integrate or to add that server to the Jupyter, well, that RTC server, to integrate it nicely in the Jupyter server. On the left-hand side, you have two blocks, which are small, but actually they are quite difficult to also to define and implement. We want to bring authentication and authorization, just to solve the identity and permissions issues, to the server. And also we want to be the less intrusive as possible and the most agnostic possible to JupyterLab. And once we have all those building blocks, we can build a nice RTC API on the client and server side, and we can integrate once again, not the integration I have shown you just a few minutes ago, but the new integration with that new library into JupyterLab. And we can allow any other developer to build an RTC, his own RTC application focus on code execution, like the notebook you all know. So that's it for me. I have put here the links to the GitHub repository, so JupyterLab/RTC. The docs, you can go from the repo, which is JupyterRTC-read-the-docs.io. And thank you to all. Thank you to CiteAs, and I'm open for any question. Now or just after, you can go and pop up to the repository. We have weekly meetings, well, bi-weekly meetings, sorry. So I think next Monday we have our next Zoom meeting also. And we look for input on any technical aspects, but also on any usability. And as a user, we need your requirement. We need to know what do you want to achieve with the RTC notebook. What is your use case? This is also something we want to, we need input for.
Well, people are thinking about it. One question I have when you talk about gathering use cases, how do you build test harnesses for these things? Like what is the approach to testing? You mentioned that on one side that there's a lot of edge cases. Do you have a lot of these edge cases sort of captured in ways that you can quickly reproduce a number of co-authoring situations?
Well, we're gonna rely on the libraries to do that. This is why we don't want, well, we have chosen to use the libraries. Those libraries are much more used than our library, and also if we meet an edge case which is not yet covered, we're gonna contribute back to that library. So in a way, the answer is let's use an existing library, and if we find other use case, we open an issue there.
Got it. Great.
Could you say something about sort of the connection between these tools and the work on annotations and annotating collaborative commenting? Because I think another important aspect of collaborative workflows is one is the inline editing, but I find, at least in Google Docs, I find that the human collaboration experience, one of the things that I really like about Google Docs is that the human collaboration experience is very well complemented by the rich annotation layer, because often it's just as important to be able to edit something in place as it is to say, this is why I made this suggestion. I made this change, but this is why, so that with a team, you can come to agreement on why was that the right approach, and then kind of merge it and accept it. So those two layers, actually, they're distinct, but they play a really important human role. And I know we've talked about this, but I'd love to hear your thoughts, because I haven't been part of the recent conversations, and I'd love to hear your thoughts on where those two layers are playing together right now.
Yeah, this is part of the, when I was giving as example, the output widget, which today is not RTC enabled. We want to ship a library which allows people to register, let's say, channels or whatever name you give. So one channel would be, hey, I am an output area and I want to discuss with another output area. we can use that, let's say, extension mechanism for the RTC library to allow people to register, so to allow developer to register their annotations, their commands on top of the RTC library. So the answer is, I don't think, well, unless we go very fast, but I don't think we're going to ship and deliver something which allow in a few months to allow the user to annotate already, but we're going to ship something, a library which allows to build on top, or for output widgets to collaborate together, or for annotation channels to collaborate and display their commands together. Because, yeah, or with an external service, or maybe if you have commands, you need to change the notebook structure, and we know it takes time to agree on a format, a JSON format, and so on. So this is why I think we don't want to build inside RTC that that annotation and command mechanism. We want the in place and so on mechanism, but we want to allow people to build on top. So that's. Thank you.
Wonderful. Thank you very much, Eric. Really appreciate that. That was awesome.
All right. Well, so thank you so much for having me. This talk is on Read the Docs, and specifically on the grant that we've received for kind of embedding content and improving the ecosystem around that. So first off, who am I? I'm one of the co-founders of Read the Docs. I'm also one of the co-founders of Write the Docs, which is a community of kind of people that care about documentation. We have worldwide conferences, so think about it like the Python or the R community, but just for documentation. And I'm also a fellow at the Python Software Foundation, and I was on the board of directors for the last 3 years, but not anymore, which is allowing me to have a little more time to do this grant, which is great. So first off, kind of, I want to do, a 2-minute overview of kind of the background on Read the Docs and where we are today. So just kind of the interesting origin story. It was actually created in the 2010 Django Dash, which was a 48-hour coding competition by 2 of these folks who have gone on to do lots of other great Python libraries and design work. And really, we just set out to solve kind of one problem, and that was like hosting documentation for our open source projects was just not that good, right? You had kind of Python packages, which was just like upload a tarball of HTML, and you had GitHub Pages, which is basically, upload a tarball of HTML in a Git repo. And really, we kind of saw this as the thing we could bring is that documentation should build automatically on every commit. And that's still kind of the core of Read the Docs today. And that's really kind of, people that are using the service, that's the value they're getting out of it. And then one of the other big things that we wanted to address was old versions and multiple versions of documentation. And so that's something we've always supported was, having a multitude of versions available for users so that you don't just have one, piece of documentation that's the latest version and doesn't match what you're using. And so we actually created kind of a workable thing in 48 hours, which is pretty amazing to be here 10 years later and be getting a grant and have such impact. So one of the cool things of the Django Dash was it required everything to be open source, and we have kept that tradition alive. So all of the code that we have for Read the Docs that host the site is all available on GitHub. So fast forward to today, where's Read the Docs at, and why is this project why are we hoping to have impact with this project? So our kind of high level stats, we publish these every year, and we have a history of doing this for the past 7 years, I believe. We have over 200,000 projects, 400,000 users. We had close to 500 million page views last year. We'll probably cross that this year, I would imagine. 20 plus contributors. And then we have a lot more of our stats published on the internet. But the takeaway here is that we host a lot of stuff. And with that, we can kind of build tooling that will then kind of enable the ecosystem to kind of move forward in a step change. You can see this a little bit with our theme, where we ship the kind of the Read the Docs theme that you see all over the internet at this point. The latest features that we've been working on are pull request building. So this is something we've wanted for a long time. So actually, auto building each commit on pull requests. This adds a huge amount of kind of resources and expense. So that's also something we're trying to manage. One of the other big things is we actually added on our search backend the ability to search for code objects. So, Python API things, are basically anything that Sphinx supports as a Sphinx object, you can search for it. And then one of the things we've been really excited about is embedding content. And that's actually what we applied for the grant for. So if you're not a Read the Docs user, it's pretty simple. You just go to the site, you register for an account, and you just put in your GitHub URL or your GitLab URL that has documentation on it, and we automatically build or pull it down and build it. And so that's really the process for Read the Docs. We have, obviously have more features on top of that, but the goal is really kind of, come create an account and kind of set it and forget it. Like you just keep working on your code and the documentation just magically gets updated. And we do love contributions. You can look at the readthedocs.org in the footer. There's a contribute link that'll actually take you to that, to our contribution guide. And especially on this project, we're not, science people. Historically, we've been building tools that's heavily used in science. And part of this goal with this work is to really kind of engage more with the scientific community and build those relationships and build tools and features that are really valuable for you all. And so is something that, especially in part 2 of our grant, where we're actually going to be writing tutorials and doing additional work, your help on that is going to be super instrumental. But I just want to talk through kind of both parts. So first part is about embedding content. And then that second part is actually about creating resources and tutorials and all that kind of stuff. So the high level here is we want to make it really easy to reuse documentation content across the web. In tech writing world, content reuse, single sourcing, these are kind of buzzwords that are all about, once you have a canonical piece of content, you should be using that everywhere you need content that's similar. And for a lot of projects, documentation websites are the canonical source where they put all their kind of information and what they want to be kind of the best resource for that project. And so we thought of a few use cases here that I'm going to show you in demos. One is tooltips inside of documentation. I'll show a demo of that. One's inline help on applications or websites. And so that, basically if you're able to kind of inline your documentation into a web UI or an application, that's something that's super exciting. And one kind of example of that kind of dovetails with the previous 2 conversations is integration with Jupyter. Like it'd be super, super cool if you were able to actually embed documentation content into a Jupyter notebook as one kind of specific example of inlining it inside of an application. And similarly, this is just a pretty simple API that we've built. And so this is also something we're hoping, we'll have additional use cases with you coming up with those. And so this is just an image example of kind of embedding documentation content. This will be a little bit nicer in the demo I show in a bit. But the way that this works is we actually have a Sphinx extension that automatically takes all of the references inside your documentation to other parts of your document and allows those to be embedded like the screenshot I showed. And then that's kind of a beta project that we have now. The work with this grant that I'm really excited about is to extend this across the ecosystem of documentation. So the first step for this is actually going to be using inner Sphinx. So basically anytime you use inner Sphinx to link to another Sphinx project, we'll be able to then automatically create references on top of those using the same mechanism. And then something even more exciting is to then extend the backend to work for any Sphinx hosted documentation, not just documentation that Read the Docs knows about, and then actually be able to kind of plug that together. So we could actually have a backend code that could work on, the same API would be able to embed any Sphinx document on the internet. And there's lots and lots, we love stuff on Read the Docs, but we also want to, support the bigger ecosystem of Sphinx documentation because there's a ton of it. So this is just an example where we kind of embedded, on the Read the Docs portal, we were able to kind of embed the documentation into the site. So that's just kind of another visual example of what I'm talking about. And again, this is fully backed by an API. So, we're able to come up with a couple interesting ideas for what to do with this, but we're really hoping that other people, already have some gears turning in their heads for what this could be good for. And we'd really love love your help, right? If we're hoping to build this API that can work across all the Sphinx content, this is something that we're going to need a lot of feedback and interaction on this work. So part 2 that I'm also really excited about is to improve best practices and tutorials in the scientific ecosystem. Similarly, we want to know kind of what your pain points are, places where, you know, writing documentation isn't as good as you want, some of the tools that you don't understand as well as you wish you did. So just really places where, you know, additional content and additional best practices can be shared wider within the community. So some of the things we're expecting here is to kind of write a complete Sphinx tutorial. We already have a lot of this content online, but that's something that I know is pretty obviously missing from my experience. A lot more on integrating, looks like it auto-corrected Jupyter and documentation. So I know there's, you know, NB convert, and there's a bunch of kind of tools around this, but I think it'd be really great to have a little bit more kind of, you know, more sets of resources there. And that's just one of the things that we've noted. And another big one is, you know, versioning of documentation. I know that's a huge topic. And so we're really hoping to kind of, you know, help people kind of build some canonical resources for how to think about solving those problems. And these are just a few of the things that we're thinking we're going to work on. Again, this is going to be kind of informed by talking to people. There's just a few of our favorite resources, but I'm going to kind of keep going so we can get to the quick demo. Just as a note, we are looking for a front-end / design person and kind of a DevRel / docs person to work on this. So if you know anyone who kind of knows the data side or the scientific side, that would be awesome, because we're looking for people to help us with this work on the grant. But yeah, so if any of this is interesting, please do get in touch with me on email or on our GitHub issues. I'm easy to find on the internet. But anyway, I did want to do kind of a quick demo, because I think a lot of this is a little more kind of understandable when you see it live. So this is just kind of our documentation that talks a little bit about how this works. So one of the cool examples I like to show is the Python documentation. So this is not live. This is actually a demo I gave to the Python core team. But here you can actually see anytime you hover over something, you get kind of the link to what it's talking about. And so these can be kind of smaller hovers. You can also set for certain types. So this is actually a module link. So this actually shows as kind of a full window. So it's just a configuration option if you have, you know, longer content versus shorter content. This is enabled by the Sphinx hover xref or hover crossref extension. So there's a few kind of interesting things here. So here's an example of it working on a Sphinx domain. So if you actually link out to a Sphinx Python object, you can kind of pull in that full documentation. It also works on some of these other Sphinx extensions like Sphinx tabs inline correctly. So that's one of the things. And I know we've been working on some of the scientific stuff as well here with the MathJax formula kind of embedded here in the page. So those are just some of the kind of examples of what that looks like. What this actually looks like on the back end is just a call to the read the docs embed API. So you can either include a project version and a path, or you can just include like the full URL here, and we'll kind of parse that data out of that URL. And that just returns, you know, pretty much some content, the list of headers on the page, and a little bit of metadata down here. So what that looks like in reality is, you know, pretty similar. I can share this link in the chat later. You can actually hit it directly. It's live right now. So one of the kind of UIs that we built around this, here is the hover xref documentation. This is kind of hidden. This isn't live yet, but you can actually go in and kind of build we have like a little selector here. So you can choose the page you want and then say, okay, I want, you know, the general settings. And then this is going to show me how to embed that in the page. And this is just like a little demo of what that looks like. As you can see, it's not super polished, but this is just kind of a little kind of UX to allow users to figure out how this is going to work a little more clearly. So one of the cool things that we're really excited about, as I mentioned, is using Inner Sphinx. So Inner Sphinx, if you're not familiar, lets you basically say, you know, I want to link to Sphinx documentation from my project, and I'm going to link it to this version. And then you can do things like, you know, I want to link to the Sphinx doc on, you know, usage of Inner Sphinx. And so when that actually builds your documentation, it reaches out to the Sphinx documentation and says, hey, what's the like canonical reference for this? And then actually lets you, that exact thing creates this this code object. So this is in our guide on InterSphinx in the Read the Docs documentation. But that's just kind of a neat example. So, I can link to the Sphinx documentation on InterSphinx, and I don't have to worry about the URL changing or anything like that. It all just kind of magically works. And this works for all the Sphinx, this works for references, it works for Python objects, it works for all that kind of stuff. And so kind of trying to be thematic here, this is the Jupyter documentation, and Jupyter actually makes heavy use of InterSphinx here. So I think once we roll this out, for example, to the Jupyter docs, it'll be a really cool experience to kind of bring in that hover feature to all of the kind of external projects. And so I think that's one of the kind of demos that I'm excited to give, some way through the grant. And so we do have kind of an example pull request on this. We haven't actually built it yet, but here you can see the hover xref is actually embedding content from the Read the Docs documentation itself. So that's the goal of that feature. We just have kind of an unmerged PR. It still needs a bunch of work, but that's kind of the vision of that work, is to start kind of pulling together this documentation ecosystem and kind of building these interrelated features between all the projects. So I believe that is my time. So that's the stuff that we've been working on, and I'd love to answer any questions if folks have them.
I was wondering. I was interested I work on the Common Workflow Language project, and we were trying to create automatic documentation from people's workflows because they do a lot of labeling and they know what the workflow is, the steps they run and the code and the Docker containers they use and all kinds of information they put in there because they're good at labeling their code. And we have a nice schema that pulls that all out and organizes, and it would be nice to be able to auto-create some of their documentation for them. And I was wondering if it would be possible then to feed that in to Read the Docs and get a nicely formatted documentation, and if I could use the API to be able to do that.
Sure. Yeah. So I mean, there's lots of examples of kind of people bringing in kind of third-party documentation tooling into Sphinx, and so there's a lot of work on doing this with Oxygen. Or Doxygen or whatever, the C library. I mean, there's lots of examples of this with JavaScript, with JSDoc, and all sorts of other things. So, yeah, I mean, I think as long as you can output some kind of structured data, building kind of a translation layer to bring that into Read the Docs and then publish it and send it out to the world would probably be the best approach there. That'd be awesome. Okay, I'll look into it. Thank you. Yep.
Thank you very much for the overview of what you're working on with Read the Docs. My question was kind of from a user experience designer, user experience researcher point of view. Do you know, or do you have a breakdown of the kinds of projects, the categories, let's say, of projects that are using Read the Docs? So something as high level as, there's science related, software development related, engineering related. And then a second question might be more difficult to answer, but if you have any idea of the most used features or tools in Read the Docs or the least used features, that would be really interesting to understand. Thank you.
Sure. Yeah. So I think the high level definitely kind of the Python community is by far our largest kind of user ecosystem. A lot of that definitely is on kind of the data science side. A lot of that is on the web kind of, Python or Flask, Django, that kind of world. And a lot of the third kind of big part there, I'd say, is like infrastructure tooling. So like Fabric, Invoke, Salt, that kind of stuff. And that's kind of just the Python ecosystem. On top of that, there's just a huge long tail of random, like Godot, which is like a C++ gaming engine is one of our big projects there. Yeah, there's just kind of a a huge long tail. Sphinx is such a kind of versatile tool that people can use it for, just about any kind of software documentation. And then there's also people writing just, resumes and pure content and that kind, books, all this kind of stuff. So yeah, but I think definitely the majority of our traffic and projects are Python focused in some fashion. In terms of like feature usage, that is something I should have a better answer to. I think it shows that we don't have a UX or kind of design type person on our team that's actually asking those questions. We do have some basic, like our little flyout on documentation pages. That's somewhere that's kind of a primary interaction point that we know is pretty weak. And a lot of what we're working on is actually extending, this isn't grant related, but kind of extending the flyout, like the PDF downloads and the versions and all that stuff, building that so users can integrate that into their themes, so that it doesn't depend on us to build a UI element for that, but it actually gives users more control over that feature set. And so we do have some basic analytics on downloads. So I think our PDF downloads are done, by maybe 3 or 4 times more than any of the other downloads. But again, that's also a tiny percentage compared to just HTML. Web views basically. But yeah, I'd love to think more about how our feature sets are used, because that's definitely something we're not great at.
Great, thank you. John Pierce, you had a question.
Yeah, I was wondering. So last time I tried with Read the Docs, it was some time ago, I must admit. And the difficulty that we had was that because it required a full install of the package and all of its dependencies in order to build the docs, because Sphinx fully imports all of the classes within the library. So at that point, CiteAs was quite hard to install in the automatic way with pip, because lots of packages, at least back then, didn't have pip installers. But even now, WX, if you're using a Linux virtual machine, then installing WX means knowing the URL for the particular WX wheel in order to install it. So there are a few things like that. Is there any solution to that yet with Read the Docs to avoid having to install at least some of the more problematic packages?
Yep. So there's a few approaches. One is kind of Sphinx Auto API, which is something we've been working on, which is kind of a parse only thing. Python makes this really difficult. There's always going to be some amount of dynamic magic in Python, so it works variably across projects. But like 90% of the information we can pull out just by like looking at the code on disk and not actually running Python. This breaks in lots of weird ways, but it generally works. Similarly, there are approaches where we can kind of mock out imports. So if your code is doing an import, but you don't actually need that in your documentation, or you're not pulling doc strings off it, you can basically just mock that out and it'll return a mock object. But yeah, that is definitely a hard problem. Similarly, we also have added Conda support. And I think we now have 8 gig memory builders. So we're also, increasing the ability to kind of build the scientific stack. And so I think having, Conda gives a lot more people that capability. So I think those are probably the best kind of pathways there.
Wonderful, thank you very much. There's a lot of conversation going on in the chat as well, Eric. So you might want to dig in there. There's some.
Yeah.
Chris Holgraff may have answered the questions around Jupyter books specifically, and Jean-Marie has a question about indexing of content.
But definitely feel free to reach out to me, and I'm happy to kind of. I really do want to talk to folks more, because we're trying to solve your problems, and we don't know what they are if you don't tell us. So.
Super. So let's move on to James Howison and CiteAs.
Excellent. Thanks so much. Well, we are working to help scientific software get cited more. And this work started when I worked with a doctoral student, Julia Ballard, and I'm just going to turn screen sharing on. And we looked at how software was being cited in the literature. So we actually went through, read a bunch of articles on the order of 100 bio articles. And we actually looked at how software was being cited and when. And so this figure is taken from the paper with Julia. And what you can see here, this is proportions or percentages. So we saw that of the software that actually ended up mentioned in the papers, which of course is orders of magnitude less than the software that was used by the researchers, these were what the mentions looked like, right? So we had about 40%, just under 40% were citations to some form of publication, whether that be a software paper or you know, a domain science paper. We also saw cites to user manuals. We saw cites to names or websites. We saw a fair amount of people citing code as though it were an instrument, right? So Microsoft Excel, Microsoft Corporation. We saw some URLs. We saw a bunch that were just the names of the packages. And my personal favorite category was not even a name. So these were mentions that were just, we used software to do X. So obviously a lot more software used than that, but you know, real questions about how to cite it, how to work on it. Since then, of course, this was quite a while ago, lots of people have, you know, have done work on this. Sorry, my Zoom window is jumping on top of what I'm trying to change to. There we go. Oh, this just shows it real quickly that the problem persisted even in like very top journals, right? So this was the data set that we looked at. We stratified what we looked at by impact factor. And so, you know, these proportions were a little better in the very top journals, and a lot more irregular in the less well, perhaps curated journals, but still a big problem. So I'm sure I don't have to convince you that, you know, improving citation across the board is worthwhile. So CiteAs tries to bridge this gap. And so I worked here with Heather Pivovar and Jason Priam, who worked on Impact Story and are now working on Paywall. And Kaifan Du, who's on the call, a student I'm very proud to work with, worked on this as well. So the bottom line is that people who make scientific software do request citations, but the ways they do it are quite irregular, right? And so what we found in the small data set that we looked at was about 147 packages or mentions of publications. We went out and we looked at who's making requests, and only 27 of those made identifiable requests for citation, right? So this is just sort of imagining a person sitting at the keyboard, remembering that, you know, oh, I used Nextflow, how do I cite it? And if it's not there right at that moment, that request, if it's not easy to know what the authors want cited, then it's harder to imagine those citations making their way into publications and becoming a resource that demonstrates the impact of the software, but also helps the community know about the software as scientists read papers, and therefore helps the community coalesce on the software that it's using. So CiteAs was funded by the Sloan Foundation as part of a larger project on software citation. And I'll talk about some of the additional components to that as well. But let's go ahead and take a little look here at what it actually is. So we'll come to that one in a second. So this is what it looks like. You know, all research products deserve credit. So get the correct citation. And if you go to that website, if you go to citeas.org and, you know, you click through, these are some examples here, and then I'll show some examples brought up from the packages, you know, that I know are here at this meeting. So this one is the, clicking through here is the YT project. And what's happening in the background here is a specialized web search, right? So it is going out and it's looking at places that people tend to make requests for citation. It needs some sort of input to get started, and then it uses a set of heuristics. And I'll tell you what those heuristics are. They're not perfect, but perhaps they're useful. And perhaps by running into issues, we can find out new ways people are requesting citations and bring them in here. Okay, so this one works. As you can see, it's prepackaged. And this provides, you know, the requested citation here. You can do the things that hopefully you'd expect to be able to do, which is download it in EndNote RefWorks. If you hit your Zotero button at the moment, it'll suck this in as a requested citation. And the citation provenance tells you what CiteAs actually did in the background. right? So looking in the user input, we found a link to this web page, and these are the things that we start to look for, right? So we look for a CiteAs relation header. I can't say I've ever seen one of those, but that'd be nice. We look in the web page itself and look for a DOI and make the outrageous assumption that landing pages for projects would have DOIs, which would be their request for citation. We look for archive pages. We also look for repository pages, right? And here we find a GitHub repository. We look in the main page, the README, for a DOI. We look for some specialized files that people use to give information. So code meta is one, and a citation file, which is a free text file in the top level of the GitHub repository, is a informal emerging standard of where people provide information about how to cite the package. Within that, there's a DOI. One of the cool things is once we have a DOI, we can actually and this, I didn't know about this until Jason was like, yeah, this is no problem. Once you have a DOI, you can get the registered metadata with the DOI in formats that you can then download it. And so that then gave us that. So if we have a look, for example, this is what the YT project is providing as their request for citation. And you can see this is a human readable freeform text file where you can provide any information you want. And we just go through and, in a very dumb fashion, just take the first DOI there. But by providing the provenance, if things don't look right, hopefully people can go back through and take a look at that. So that's one way people are making a request. Another one, in different ecosystems, there are ways in which requests for citation are already recorded, right? So here's a link to an R package, and assuming everything goes correctly, this will go through. It recognizes, oh, hey, I'm on CRAN. I should look for a citation file. But I also know that if I'm in the CRAN world, I can go and look for an R description file. And once I find that, I can parse out these data. And this just shows you kind of where it actually came from, right? And that then enabled us to create that citation for download. So just to give you an idea of some other examples. So here we have projects from around the world. And this one goes from a GitHub URL, finds, downloads that, finds the DOI response, and finds that citation metadata. So that's one way forward. You might recognize some of these packages. Shows different ways that we can take input, different ways we can start. We can start with identifiers that are out there, like archive IDs. We can do I think PubMed Central IDs. I think that there are other opportunities. I know that the resource descriptor RRID has other identifiers. So whatever is out there and being used, CiteAs is trying to be open to find that. So here's an example of going from a Git, starting straight with the DOI. We'll just provide an interface to the DOI APIs to grab those data. These ones use code meta files. And that one grabs the code meta file directly. Okay, so in theory, this could be useful. We see this being used as people are writing papers, but we also see it being used as we're all reviewing papers, right? So, if the person just says, oh, hey, I used, this package, and they don't provide a citation, then, as reviewers, we can say, oh, hey, it'd be good to provide the citation for the software you used. Go hit up CiteAs and find their requested citation. So I'm sure you guys can think of other ways this could be used. So I tried this out on a few packages from the from this meeting. So Nextflow. And so you can start in a number of different places. You can start at project landing pages. You can start with a word And what we're actually doing here in the background is combining that word with another word and doing a Google search. Combining that word with how to cite or request for citation or just citation as a starting point. So that does not always work, as you can imagine. So let's see. This one will come up. There we go. Okay, so they were able to find the Nextflow website, but claims it doesn't find a DOI, goes over to GitHub, goes down to the README, claims it still doesn't find a DOI, and falls back to the GitHub repository API response, right? So a fallback is often these data on GitHub, which are often not that well filled out. And so what we hope would happen then is someone would say, oh, hey, we could improve things. And so somewhere on this page, as you know, this being the Nextflow landing page, you know, having a DOI or a request for citation, you know, might make sense. And so we hope that people would be able to observe this provenance chain and make some improvements there. Now I had some other demos. Let's see. So Xarray is another program funded here. And this one certainly seems to work better. And sometimes it comes back with one and I look closely and I'm like, that's not the right one. But here, this is able to look and find this FAQ and in there find a DOI and pull that up. I hope that looks useful to the people doing it. So obviously the way we're doing this can run into some issues. So this is Rocker. So if I search for Rocker, I somehow get Zotero, which doesn't make much sense. I also found Rocker had a name conflict before with another package. But some others do work. Sorry, so this is OpenSim. So this is falling back again there to the GitHub metadata. You know, if you start in different places, different things happen, so that is not ideal. So this is not finding these things for the packages that are a part of this program, is a combination of sometimes they're not being requests, but also CiteAs not having, the smartest logic in the world. So that's an opportunity, right? We have an open source site, we have a GitHub site, we have an opportunity to contribute, we have an opportunity for y'all to submit bugs and to move things forward. So I would appreciate, people searching for theirs, and if it doesn't work in the way you'd expect, go ahead and fill this form out, or you can dive over to CiteAs API on GitHub and submit a better issue there. Of course, a pull request is good too. So we provide these options here for the provenance. So this just kind of goes ahead and suggests some logic. So feel free to point out better logic or places that we're missing things. This citation file is useful. Code meta is useful. There's also a machine readable format called citation.ccf, which provides some fairly straightforward YAML-like metadata for additional citations. So looking forward to your input. I do want to point out one other thing, which is eventually we hope we are going to integrate CiteAs with work-derived, also funded by Sloan, around the soft site data set. So here we've taken a much larger data set and annotated full text mentions in papers. And so you can see the work here, working with Patrice, who wrote Patrice Lopez, who wrote Grobid, which could convert those PDFs into actually usable XML, which we can then annotate and data mine on. And so we're working there to data mine the open paywall, open access set to create mentions. And we'll have a lot more opportunity to talk about that possibility in the workshop in the next session with Karthik Ram. Okay, so that's the presentation that I have there. And love to hear your comments, questions, bug reports. So go for it.
Well, you've already got at least one person adding a DOI to their repo right now to improve it, so this is good.
Thank you. My video appears not to be working as soon as I have my webcam on for more than an hour just now. It seems to overheat and just pack it in. Thanks for the demo, James. The question I was wanting to ask is whether you've talked to any of the tools people who develop the sort of like the browser plugins for clipping citations, or the citation manager folks, to get your API used in those tools. Because I think what you've done is amazing, but the kind of key to adoption would be to get it in the hands of the people who find software citation already difficult, rather than the ones who can probably work it out already based on the rules that you've encoded there. So any word on?
Yeah, okay. No is the answer. Yes, we should. You know, the idea of this is as a small API that just kind of sits in the middle, right? So the website is just one instantiation of it, but yes, you know, we should be able to do this via Zotero, things like that. You know, maybe some of the logic could be replicated over, you know, could be abstracted out and replicated in tools' own code base, so they're not relying on that API specifically. But drop links in for the clippers and the, you know, the ways that you think things are trying that. And we should promote that.
Hi, James. Really enjoyed hearing more about CiteAs. As I think about what we're trying to communicate with a citation, it's really, as was mentioned in the chat, it's the currency of academia that we want to be cited, and that citations are a way that we're measured, and software is not recognized. And so you're showing us a path, many paths for getting our research products that are not papers cited. And I'm wondering if there was one, should I use this? Which of these formats do you think is the easiest to interoperate with? Like, is getting a DOI the most important thing? Is a citation?
Well, so I think, yeah, so I would specify that your number one move is put a citation file in the root of your directory, right? And that when that has metadata in it, we can parse it out. So you can just use BibTeX. If it has a DOI, that's a lot better, obviously, for many reasons.
Yeah.
And as a fallback, making sure that your GitHub repo has some reasonable information, you know, in that API makes the most sense. Code meta and citation.cff are machine readable forms of the citation file, but there's a lot more that you can say in free text in the citation file itself. And as long as the, you know, the DOI is in there, then tools can start to interoperate.
Okay, thank you.
But I also, I don't know that the world of people who are citing software or coming up with persistent identifiers for software is necessarily coalesced on DOI as being the persistent identifier. So there are also the software archive identifiers for things that are going into that and others. So
right, and as Alex, that's a really good point. As people, you know, come up with those, like, I think the approach here is, and I think it was John Postel in very early days who said, you know, be open to what you receive and strict about what you export, right? So that's the idea here. So if people come up with other identifiers and things that we could add in, or just logic like, oh, we put it on a citing.html page, right? That's fine. We can work with that too. Great, fantastic, please.